Alright, so we're continuing this example. I finished halfway through it, or I got halfway through it on the last video, and I ran out of time, so we're going to pick up right where I left off. So again, quick recap. We have a central angle here, highlighted in pink. We have a central angle that we know is 72 degrees. We know that because we divided 360 by 5, because that's how many side lengths there are. When you draw the apothem, which drops down and forms a 90-degree angle, it bisects the central angle, which means it creates two 36-degree angles. Right? So now we can just use trig functions. If we're dealing, I'm going to draw this triangle that I'm referring to. I'm going to draw it, as a separate thing here. If we have, this is this pink triangle that I just drew on the side. We know that this is 36. And we know that it's 90 degrees there. We know that this is also 10. We need to find A. We need to find X. Right? Well, the first thing we can do is find A using one of our trig functions. So cosine, sine, or tangent. Well, this central angle, half of this central angle, this 36-degree angle here, is adjacent to the A, and 10 is the hypotenuse. So I'm going to use cosine in that case. I'm going to say cosine of 36. Again, so right? Cosine is the adjacent over the hypotenuse. So cosine of 36 is A over 10, which means if I want to solve there, I just get A equals 10 cosine 36, which is approximately, A is approximately, let me type this onto the calculator real quick here. 10 cosine of 36, which is approximately 8.09. So I'm going to say 8.09. Now we can do a similar thing for x. We can do sine of 36 because x is opposite the 36. So I can say that sine, I'll write this more to the side to save space. Sine of 36 is the opposite, which again, the opposite goes down here, right? The opposite is x over the hypotenuse, which is 10. So x equals 10 sine 36, which when you type that into a calculator, you get 10 sine of 36. Again, make sure your calculator's in degree mode. You get 5.88. You get approximately 5.88. So what have we gotten? Well, we know the apothem. It's approximately 8.09. We don't know P yet, though, right? We don't know the perimeter, but we do know X. Well, if I want to know the perimeter, it's just this side length and this side length, right? It's all of my side lengths added together. So there's two ways of thinking about it. There's two strategies, both of which are acceptable. The first is you have this length X. Well, how many times does X go into the perimeter? Well, it's another time here, 3, 4, 5, 6, 7, 8, 9, 10, which again makes sense, right? Because each of my 5 side lengths is cut in half. So if I want to find my perimeter, I would say my perimeter is just 10 times x, right? Or 10 times 5.88, which is 58.8. The other strategy is to first find your side length here, right? To find your side length here, which is just double x, and then multiply it by 5 because there's 5 sides in total. So, I mean, it's really up to you. It's just based on preference. So then, anyway, to plug this in, we need to find our area, right? We're not done with the problem yet. So we need to find our area. We get A equals 1/2. The apothem is approximately 8.09. And the perimeter is approximately 58.8. So we just, again, using a calculator here, we end up with 0.5 times 8.09 times 58.8, which gives you 237.85. So the area is approximately 237.85. Did I tell you what the units are? No, so we call it units squared, right? Remember to always put meters squared or feet squared or whatever it is you're doing there. Okay, so that's kind of how trig comes into play here. So if you don't understand your trig, then you're not going to understand this chapter, which is not good. So if you don't understand your trig, go back and look at my trig videos or ask me questions separately. Let's look at another example. So it says find the area of a regular octagon with a perimeter of 48 meters. So they don't give you a picture here. You kind of need to draw it yourself, if you so please. So I'm going to draw an octagon. Bear with me here. It's tough to draw an octagon. In fact, I should have thought of that before I decided to choose an octagon. All right, so it has the perimeter of 48. Well, do I know what do we need? First of all, we need 1/2 AP. Well, we already know P. It's given to us, right? We know the perimeter. It's 48, so that's good, right? So now all we need to figure out is the apothem. So again, I'm going to draw my center here. I'm going to form my central angle, which again, the central angle is just 360 over 8 because there's 8 of the central angles, which gives me 45. Okay, so this central angle here is 45. Now if I cut that in half, that means each of these is 22.5, right? 22.5. I just cut my 45 in half. Okay, so now what do I need to do here? I need to figure out my apothem. Well, I know my perimeter, but do I know my side length yet? I don't. It's kind of there, but I haven't, actually written it out yet. So if I'm looking for my side length, my perimeter is 48, and how many sides are there? Well, there's 8 of them, right? So my side length is just the perimeter divided by 8, which in this case is 48 over 8, which is 6 meters, right? So my side length here is 6, meaning each of these small parts here, these are congruent. Again, the apothem cuts it into 2 equal pieces. So each of these here would be 3, right? So in order to find my apothem, which is this side length here, I need to again use a trig function. Okay, so the trig function that I'm going to use, I have a 90-degree angle, I have both of the legs. I have both of the legs and I have an angle. So I'm going to use tangent. Tangent of 22.5 is what? The opposite, which is 3, over the apothem, which is A. So when I solve this, I get A equals 3 over tan 22.5, which you're going to type into your calculator. 3 divided by tangent of 22.5, and that gives you 7.24. Approximately 7.24. So now all we have to do is plug that in. We have the area equals, in fact I'll do this in a different color so it's not confusing. We have the area equals 1/2 AP. We know that it is 1/2 the apothem, which is 7.24, times the perimeter, which is 48. Plug that into your calculator, you get 7.24. You end up with 173. I'm going to round here. The area is approximately 173.76. What's my unit? Well, it says 48 meters up here, so square meters, which would give you your answer. Okay, so that's kind of how we use, it's kind of another interesting question that they can ask you where they give you the perimeter and you have to kind of work backwards in some parts.